Students, today class state and prove the law of conservation of linear momentum. So previous videos now know the important laws, Newton's laws of motion, first law, second law and third law, and mathematical formula force equal to mass into acceleration. Now today this class state and prove the law of conservation of a linear momentum. This question is very important. Students, this is a 5-mark question. It is very important. You practice number of times. State and prove the law of conservation of linear momentum. So how to understanding law of, so many laws are there. Law of physics, conservation of energy, conservation of momentum, conservation of charge. Now here state and prove the law of conservation of linear momentum. Now this is one system, isolated system. In this system, a number of particles are there. A number of particles. Number of particles are there. When force is applied, F is a force applied to the body. After force is removed, so within system, within body, the particles are interact. The particles are interact. Sum of the two particles before collision equal to sum of the two particles after collision. So according to statement of conservation of linear momentum, the total momentum of an isolated system of interacting particles are conserved. Now students, this is one system, around body is there, a number of particles. When force is applied, after external force is constant, the particles are interact. The total momentum of an isolated system of interacting particles are conserved. Some of the particles before collision equal to some of the particles after collision. The two particles are collide to get the conservation of a linear momentum. Now the clear statement, the total momentum of an isolated system of interacting particles are conserved. Now example here, two bodies. The two bodies are there. The first body A. A is the first body of mass m1 moving with initial velocity u1. The first body A of mass m1 moving with initial velocity u1. The another body B, mass m2 moving with initial velocity u2. Consider, now students, two bodies are there, A and B. A is the first body of mass m1, initial velocity u1. The another body B of mass m2, initial velocity u2. So now two bodies are there, A and B. The first body of mass m1 moving with initial velocity u1. Another body B, mass m2, initial velocity before collision. So after two bodies are collision or impact, two bodies are collision or impact, A and B are impact. So change for its kinetic energy. So body A, final velocity v1, mass m1. After collision, so another body B, mass m2, kinetic energy v2. Now students, you observe two diagrams are there. Two bodies A and B of mass m1 and m2 moving with velocity u1 and u2 before interaction, before collision. So after two bodies are interact or collision, their final velocity, the first body of mass final velocity v1, second body mass m2 final velocity v2. So after collision, some of the particles before collision equal to some of the particles after collision. More than two particles are colliding with each other to get the law of conservation of linear momentum. Now before collision, here what? m1 u1. Already know the momentum. Momentum P equal to m into v. The product of mass of the body and its velocity is called a momentum. So now here m1 u1 is an initial momentum. M1 V1 is a final momentum. Now the first body change its momentum. Final momentum minus initial momentum, that is the change in momentum. Change in momentum. Change in momentum of a body. Change in momentum of a body A. Change in momentum of a body A. Before collision, the first body A, initial momentum m1 u1. After collision, final velocity v1 for first body, so final momentum m1 v1. Now change in final momentum m1 v1 minus initial momentum m1 u1. Change in momentum of a body, change in momentum of a body equals what? Final momentum, where final velocity v1, therefore final momentum according to formula momentum equal to mass into velocity. So final momentum m1 v1, initial momentum m1 v1 before collision. Change in momentum takes place time 50 seconds. So change in momentum takes place at time 50 seconds. That is the rate of change of momentum. Rate of change of moment. Rate of change of momentum. Rate of change of momentum of a body. Rate of change of momentum of a body A equals, so m1 v1 minus m1 u1 by t. Change in momentum takes place time t second. That is the rate of change of momentum of a body equals m1. So m1 v1 minus m1 u1 by t. Now observe students here, change in momentum of a body equal to m1 v minus m1 u1. Rate of change of momentum of a body A equal to m1 v1 minus m1 u1 by t. So after the two bodies are interact, the force exerted on a body B by a body B on a body A, so that is F2. So F2 equal to m1 v1 minus m1 u1 by t. The force exerted on a body B by the body A. So force symbol F. Now you denote symbol F2. F2 equal to m1 v1 minus m1 u1 by t. That is the rate of change of momentum of a body according to Newton's second law, directly proportional to applied force and takes place in the direction of the force. The force exerted on a body B on the body A. So F2 equals m1 v1 minus m1 u1 by t. Similarly, the change in momentum of a body B. Change in momentum of a body B. Change in momentum of body B. So body B. Change in momentum of a body B equals what? The second body, mass m2, initial velocity u2, initial momentum m2 u2. After collision, so final velocity v, so m2 v2 is the final momentum. So change in momentum of a body B, m2 v2 minus m1 v1, m2 v2 minus m2 u2. Now students, you observe here what? So final momentum of body. So a body B, final momentum m2 v2 minus initial momentum of the second body m2 u2. Now m2 u2. So change in momentum of a body takes place time t second. That is the rate of change of momentum of a body. The rate of change of momentum of a body equals what? m2 v2 minus m2 u2 divided by t. The rate of change of momentum of a body B m2 v2 minus m2 u2 by t. So these mathematical steps are very important. So I repeat one more time here. Change in momentum of a body A. This is a body A. The body A mass m1, initial velocity u1 after collision. So final velocity v1, momentum for m1 v1. So m1 v1 minus m1 u1. The body collision after time t second, the change in momentum takes place time t second. Rate of change of momentum of a body A equals m1 v1 minus m1 u1 by t. So rate of change of momentum of body. The force exerted on a body B on a body A F2 equal to m1 v1 minus m1 u1 by t. Similarly, now second body of mass m2, initial velocity u2 after collision, final velocity v2. So change in momentum of a body B. So here what final momentum m2 v2 minus initial momentum m2 u2. Now rate of change of momentum of a body m2 v2 minus m2 u2 by t. Now the force exerted on a body A by the body B, that is F1. So F1 equal to m2 v2 minus m2 u2 divided by t. The force exerted on body A by the body B. So F1 equal to m2 v2 minus m2 u2 by t. Now according to Newton's third law, for every action there is an always equal and opposite reaction. So now this is the reaction, this is the action. So according to Newton's third law, here F2 equal to m1 v1 minus m1 u1 by t, and F1 equal to m2 v2 minus m2 u2 by t. So now here F1 equals minus F2. F1 equals minus F2. So according to third law, action and reaction are equal and opposite. So this is the reaction, this is the action. So now substituting F1 value what? M2 v2 minus m2 u2 by t, and F2 value. So F2 value what? Equals minus, here minus is there. So m1 v1 minus m1 u1 by t. According to Newton's third law, F1 equals minus F2. Now F2 equal to m1 v1 minus m1 u1 by t. F1 equal to m2 v2 minus m2 u2 by t. So F1 equals minus F2. Now substituting what? So F1 value and F2 value. So now here what happened? So left side denominator t, right side denominator t, both are cancelled. So m2 v2 minus m2 u2 tt cancel. So minus to multiply minus m1 v1. So now minus into minus what? Plus m1 u1. Now students observe here, denominator left t, here also this t cancel. m2 v2 minus m2 u2. Now right side, the negative sign is multiplied. So minus m1 v1 minus m1 v1. Minus into minus what? Plus m1 u1. So after you rearrange this equation, minus m1 v1 take left side. You take left side. This one. Minus m2 u2 take right side. So now this side. So minus plus m1 v1. So after this go to right side, m1 u1. So now take this side, so m2 u2. So this equation written as m2 v2 plus m1 v1 equals m1 u1 plus m2 u2. This equation written as, first you this way, this one write first one, left, m1 v1 plus m2 u2 equals, after write this one, m1 v1 plus m2 v2. Now students, you observe this equation is very important. The first body of mass m1, initial velocity u1. Second body of mass m2, initial velocity u2. This is the before collision. Before collision, no change for velocity. So right side, first body of mass m1. After collision, final velocity v1 for first body. So second body mass m2, final velocity u2. So according to this law, this equation states that sum of the momentum of the two bodies before collision equal to sum of the momentum of two bodies after collision. So the momentum formula P equal to, so P equal to m into v. The momentum P equals m into v. Now the first body what? A of mass m1. So first PA. So PA. Second body B mass m2 plus PB equals, okay, after collision final velocity v1, that is P dash A plus PB dash PA plus PB, momentum of two particles before collision. P dash A plus P1, momentum of two particles after collision. So this equation is very important. m1 u1 plus m2 u2 equals m1 v1 plus m2 u2. Sum of the two particles before collision equal to sum of the two particles after collision. According to statement, the total momentum of an isolated system of interacting particles are conserved. This is a statement and mathematical formula m1 u1 plus m2 u2 equals m1 v1 plus m2 u2. This equation written as m1 u1, that is PA, first body A of mass m1 u1. So momentum equal to mv equal to PPA plus PB plus P dash A plus PB dash. This is the final expression for conservation of linear momentum.